Students and friends, welcome to my YouTube channel. Today I am going to discuss one derivation in the impulse turbine. So how they will ask the question. These questions and all they are asking oftenly university exam or some competitive exam, and so many inside basic concept will be there for the solving the objective questions. So carefully watch this full video. So what are these questions here? Derive the expression for the maximum blade efficiency for single stage impulse turbine. Or other way, how they will ask, what is the condition for the maximum efficiency of the impulse turbine, and what is the maximum efficiency of the impulse turbine. So condition will write, then we'll get the what is the maximum blade efficiency. That is our objective today's video. So for this, already this velocity diagram lot of times we discuss in our video. So one more time I will discuss how to draw the velocity diagram. Then all the notations I wrote that I will discuss. First you see the how to draw the velocity diagram. So just roughly we'll see. So here two inlet blade angle and outlet blade angle. Two triangles we are combining together. You see here. First we'll draw the inlet triangle. Inlet triangle we draw. This is the alpha, this is the theta. Alpha is nozzle angle, theta is inlet blade angle. This is coming Vf1, this is coming real velocity at inlet. This is relative velocity, this is steam velocity, absolute velocity at inlet. Now outlet triangle will combine. How will combine? This is theta is inlet blade angle, phi is outlet blade angle. So from here, we will make here outlet blade angle. We will make here outlet blade angle phi. So relative velocity at inlet, now relative velocity at outlet. Now again, beta is nothing but what? Outlet angle of the fixed blade. So here again we'll make the angle beta angle. We'll make. So we are drawing the acute angle less than 90 degree. We'll extend this line. Where this join together we'll go the vertical line. So this is the VW2. This is the V2. This is the V2. VF2. Now this is the blade velocity. So once we'll combine together blade velocity VB1, VB2, inlet and outlet will always come equal. So with the V, this is VB. This way we can draw this diagram. This way we can draw the inlet triangle and outlet triangle. We combine together, we got the velocity diagram of the impulse turbine. So now here notations I taken. E, A, B, F, E, D. All the notations given. Because here if you'll see, 4 triangle will be there. BFE, one triangle, theta angle. If we'll take AFE, alpha angle. If we'll see EBD, one phi angle. If we'll take EAD, this is beta angle. So from this velocity diagram, we can take the 4 triangle out. And by the Pythagoras theorem, because all will be the right angle triangle. So Pythagoras theorem, we can find sin alpha is equal to P by H, cos alpha is equal to B by H, base by hypotenuse, tan alpha is equal to P by B. So this way we can find all the unknown velocity when we will solve the question. So this velocity diagram having lot of work, lot of importance. So this is the velocity diagrams about. Now our objective is to derive the diagram efficiency or blade efficiency. So all the notations I given here. See, VWN is real velocity at inlet, VW2 at outlet. Relative velocity at inlet, relative velocity outlet. Absolute steam velocity, inlet and outlet. Alpha nozzle angle. Beta is outlet angle of the fixed blade. Theta is blade angle at inlet, phi is blade angle at outlet. Flow velocity at inlet, flow velocity at outlet. So okay, now what is our objective? Blade efficiency we have to calculate, or conditions of the blade efficiency, and what is the maximum blade efficiency. So blade efficiency is nothing but work done by kinetic energy per second. So work done already we know m VW1 plus VW2 into VB by VB, work done per second. Kinetic energy half m V1 square. So kinetic energy once will take now this absolute velocity at inlet only will take. From there we'll draw, and these are steps when we'll solve. I will explain that time. So from this equations, I am writing here blade efficiency will solve, mm will get cancelled. So 2 VW1 plus VW2 VB by V1 square. This will be the equations coming from blade efficiency. Now, how to get the maximum conditions for the maximum blade efficiency? So now look here. Here, VW1, VW2 will remove from there. Will remove. So now we can write here. Now VW1 plus VW2 is equal to, what is there here? EF. This is the VW1, this is the VW2. So we can write this is nothing but EF. Nothing but EF. So now, two blade angle is there. So two triangles will take. What is triangle? EB, EBD. So EB will take is equal to, we can write EB, then BF plus BF. We can write now EF is nothing but VW1 AF. VW1 is AF. One more steps I'll write here. See here. Okay, one more steps I'll write. Total EF is nothing but VW1 plus VW2. Also we can write here EA. So AF plus EA, nothing but VW1. AF plus EA, nothing but VW1 plus VW2. This we can write. Now, also we can write here two triangle will take now, because we have to take the two blade angle. So theta angle and this angle. So what is the EB plus, also we can say here EB plus BF also will be equal. VW1 plus VW2 is equal to EF. Now EA plus AF, VW1, VW2. Now we are taking this EA plus AF. EA plus AF. So what is EA here? EA, where this triangle. If you will take the phi triangle, EBD, this triangle EBD, triangle EBD, base, hypotenuse, perpendicular. Cos phi is equal to B by H. Cos phi is equal to B by H. So EB by BD. So EB is equal to BD. BD nothing but VR2. So VR2 cos phi. So we can write this is VR2 cos phi. BF. So this is BF, not theta triangle. So theta triangle I taken here. This distance will be BF. Distance is nothing but VW1 minus VB. Total is VW. So this much is nothing but VW1 minus VB. VF and VR1. So we need what is BF distance. So this is again cos theta is equal to B by H. So BF is equal to nothing but BC cos theta. BC is nothing but VR1 cos theta. So plus we can write here VR1 cos theta. So see this. Up to this we wrote here. So VW1, VW2 is equal to this. Now what we'll do? We'll take VR1 common. VR1 cos theta will take common here. This side it will come 1. So this side what will come? VR2 cos phi. If we'll take common now, it will come VR1 cos theta plus 1. Because we are taking common VR1 cos theta, we taken common. So suppose here see. Suppose 2 plus, some example, 2 plus 5 is there, or 2 plus 8 you write here. Take common 2. Take common, suppose this 3 plus 8. Take common 8. Take common 8. What will come? This plus this part will come 1, 8 common. Here what will come? 3 by 8. Something for understanding. So see, if you are taking this side common, or you can say here, divide VR1 cos theta in this equation. So here VR1 cos theta 1, this is 1. That way also you can understand. It's okay, now we know this. Now next step, VR1 cos theta. What is VR1 cos theta? We'll write now here. VR1 cos theta is nothing but BF. BF equal to VR2 by VR1. VR2 by VR1 K, not wrote somewhere. K is equal to nothing but VR2 by VR1. So VR2 by VR1 is K, friction factor. So this we can say K, and cos phi, cos theta here. C, some constant we are taking, cos phi by cos theta. Cos phi by cos theta taking C plus 1. We reduce the term because we have to differentiate. Reduce the term. Now, again, what is the BF here? VR1 cos theta. VR1 cos theta. So that will write VW1. BF is nothing but VW1 minus VB. Then here what is? Kc plus 1. Kc plus 1. Again VW1 come. Again we have to remove. So our target is to remove the VW. What is VW1 plus VW2 is equal to in terms of other velocities will write. So again VW1 is came here. So again VW1 is equal to what is? If you take the angle AFE, triangle AFE, consider the triangle AFE. What is? Cos alpha is equal to B by H, VW1 by V1. So VW1 is equal to nothing but V1 cos alpha. So now you write here in this place V1 cos alpha minus VB, then here Kc plus 1. So these equations now we got. Now what we'll do here? Say VW1 I wrote here, V1 cos alpha. Okay. Now you give this equations number 2 because VW1 we removed. Give equations 2. Now substitute equation 2 in equation 1. Substitute equations 2 in equation 1. So what will come? Blade efficiency here? 2 already there. What is this value came from? VW1 plus VW2 is equal to this value. This value nothing but VW1 plus VW2. What is this one? V1 cos alpha minus VB Kc plus 1. Okay. So now this is the equations came here. Now here we write VB by V1 square. So blade efficiency. We substituted in equations 1, 2, VW1 plus VW2. This is the value of VW1, VW2. We will write here. This value is nothing but VW1 plus VW2. This value is nothing but VW1 plus VW2 value. Now substitute. Now VB will take inside. So first what we'll do here is step C. Kc plus 1 you take outside. Not outside. Yes, into now. So can take outside. So now what we'll write here? 2 also you can take outside. Now V1 cos alpha minus VB into VB whole square, whole by V1 square. So this error. Now VB will multiply here. VB will multiply inside. So okay. So one more step. What is? 2 Kc plus 1 V1. If you will divide also parallelly, now see these steps right directly. VB first multiply. What will come here? And divide by, see here, V1. Okay, write one step so it will be easy for you. So V1 VB cos alpha minus VB square. We can write this. Divide by V1 square. Now V1 square will divide both sides. So here you write same as it is 2 Kc plus 1. Now V1 divide by V1 square. So what will come? VB by V1 cos alpha plus here what will come? VB by V1 whole square. So this we can write now. Now VB by V1 is nothing but speed ratio. VB by V1 blade speed divided by absolute velocity is nothing but we are taking symbol, take rho. Symbol take rho. Rho is nothing but speed ratio. Rho is nothing but speed ratio. So we'll write here. What will be there? 2 Kc plus 1. Now this is Vb by V1. What is? Rho cos alpha minus rho square. Rho square. Give equations number 3. This we got. So we reduces. This is rho is nothing but speed ratio. Now what we'll do? We'll differentiate this. So if you'll see the conditions for the maximum blade efficiency, differentiate equations 3 with respect to rho. D by blade efficiency, differential blade efficiency with respect to d rho. D rho. D by d rho blade efficiency. D by d rho blade efficiency. You can write like this also. D by d rho blade efficiency and equate equal to 0. So how we'll get the conditions for the maximum blade efficiency? Differentiate equation 2 with respect to rho and equate it into 0. So if we'll differentiate this, we'll get the some relation. So now you see here, I will write here itself. I'll write notations also. I remove it. Okay. Now look here. Now I'm writing here. So differentiate this and equate equal to 0. So this is the constant because differentiating with respect to rho, speed ratio. So this will not write. So one more time, what we can write? D rho cos alpha minus rho square and will equate into 0. So what is differentiation? What is differentiation of the uv? U dv plus v du. This is a differentiation. So suppose rho is u, this is v. So what is differentiation here? First u, rho. Differentiation cos alpha 0 with respect to rho plus cos alpha, that is v du into 1 minus 2 rho equal to 0 because rho square differentiation is 2 rho. Like now x square differentiation is 2x with respect to x. With respect to rho square 2 rho. Now what will come here? This cos alpha equal to 2 rho. So rho is equal to cos alpha by 2. What is this one? This is the conditions for the maximum blade efficiency we got. This what we got here? Conditions for the maximum blade efficiency. We will write here by 2. Nicely we will write. This is the conditions for maximum blade efficiency. See, so this is the conditions for the so many objective questions. They will ask this formula we can use. What is the conditions for the maximum blade efficiency? This. Now what is the maximum blade efficiency? Now maximum blade efficiency what is? If we will substitute these conditions for the maximum blade efficiency, we will get the value. Three. So equations 3, where is equation 3 here? So substitute, or give equations 4. Substitute equations 4 in equation 3. So we will get the maximum blade efficiency. What is? 2 Kc plus 1. Now what is here rho? Cos alpha by 2. Cos alpha by 2 and cos alpha already there. Cos alpha is there minus rho square. Rho square nothing but cos square alpha by 4. So we substituted there. What we did? Conditions we got, that conditions we substituted in the equation 3. So now we'll solve, we'll get the maximum blade efficiency. Now we'll solve, we'll get the maximum blade efficiency. So okay. So what is there? 2 Kc plus 1 cos square alpha by 2 cos square alpha by 4. That means see here 1 by 2 minus 1 by 4. How much will get? 1 by 4. So cos square alpha by 4 will get. Cos square alpha by 2 minus cos square alpha by 4 will get cos square alpha by 4. Now 2 get cancel here. So what will get here? Kc plus 1 cos square alpha by 2. So this is, what is this one? Maximum blade efficiency. We got the, this is the maximum blade efficiency we got now. We got the maximum blade efficiency. We got the maximum blade efficiency. Now some conditions will apply. So if neglecting the blade friction na relative velocity will be equal. If relative velocity be equal, K is equal to, I know, VR2 by VR1. If neglecting the blade friction, if neglecting the blade friction, that means VR1 is equal to VR2. Relative velocity will be equal. That means K is equal to 1 will come. And blades are equiangular. That means, that is inlet blade angle equal to outlet blade angle. That means C is equal to what we wrote here, cos phi by cos theta. Both will equal me C is equal to 1. And here also we are getting K is equal to 1. This is the maximum blade efficiency we got when considering the friction and inlet blade angle, outlet blade angle are not equal. Then this is the formula. 1 plus Kc cos square alpha by 2. If only they will ask neglecting friction, then K is equal to 1. So C plus 1 formula. If blade are equiangular, then theta is equal to phi. Both conditions will be there. Both will be 1. So 1 plus 1, how much will come? 1 plus 1 cos square alpha by 2. So this 2 get cancelled. So what will get from this? Maximum blade efficiency if applying the condition cos square alpha only. So maximum blade efficiency, what we got? Cos square alpha. Maximum blade efficiency is this, when considering friction and blades are not equal. If both are equal and considering friction, cos square alpha. So this is the derivation plus a lot of concept, objective questions also will be there. So okay students, watch this video, share this video to your friends and subscribe the channel. You will get the more and more video in this new video you will get. Okay, thank you.